Whether in movies or in real life, there's a good chance that they have seen lasers. Like laser guns or laser cutting, they are known for making things hot, which is what they normally do. But there's another surprising thing that lasers can do, making the coldest materials in the world. Now at first, this may seem confusing because how are we supposed to cool something with lasers? After all, when we cool something, we basically decrease the average kinetic energy of its atoms. However, lasers carry energy, and as we all know, it will increase the object's temperature. So how is it possible? Well, one interesting thing about lasers is that it consists of photons, which in addition to energy, they also carry momentum. And since the atom also carries momentum, we can use the idea of momentum transfer from the laser's photons to the atoms. If there's an atom and a photon moving towards each other, the atom will absorb and re-emit the photon, which on average will decrease its momentum. But there's a catch. Atoms are quite picky. See, the thing about atoms is that they can only absorb specific wavelengths of photons. Therefore, only photons with the right wavelength can be absorbed by the atom. What's the wavelength? Well, it really depends on the atom itself. When an electron inside the atom jumps from a higher energy level to a lower one, it releases a photon of a certain wavelength. We call it the transition wavelength, which is the exact wavelength we are looking for. If say a hydrogen has a transition wavelength of 122 nanometers, this means that the photon of the same wavelength has the highest chance of getting absorbed by the atom. And if we try to use other wavelengths, the absorption probability will decrease the further we move away from the transition wavelength. So now we know what the best wavelength is, we can start setting up the cooling system. The laser can be tuned to the same wavelength, although it is best to tune it slightly longer than the transition just to compensate any Doppler shifting or squishing of the wavelength. And if one laser is to slow down atoms moving in one direction, then we need 6 lasers to effectively counteract them in all directions. Shine them into the center, and there we go. We have ultra cold atoms. And that's laser cooling, and like I said earlier, it can bring atoms to super cold temperatures. Microkelvins, just 1 millionth of a degree above absolute zero. And with something this cold, we are able to produce more accurate data and make more precise measurements, which is why atomic clocks, GPS, and even your phone use this incredible technology of laser cooling. So yeah, lasers really can make something cold, because lasers are cool, right?